how's it guys, and welcome to my channel. As usual, I just want to start off by saying thank you to all you guys who give my videos a view, all the positive comments. I really appreciate it. Thank you guys so much. The title for today's video is, Are Flat Earthers More Boring Than Me? I am kind of boring in the sense that I don't go onto roller coasters. I'm kind of afraid of heights, but I was in the big wheel at Gold Reef City many years ago, and I was behaving like a meerkat, you know. I was like, just my eyes were peeking over the edge of the basket so I can check out the view. But otherwise, I am terrified of heights. I don't like to watch really gory horror movies. Like, I can watch Underworld, but I won't watch something like Poltergeist. So my friends always tell me, "Oh, Sal, you boring." My idea of fun is having a smoke under the stars, maybe a braai, some nice music. That's my kind of fun. So us as humans, we have learned to understand the information we are finding out and then categorize that information so others can also better understand the information that is being gathered. So us as human beings, we are quite clever, but we use colors opposite of the universe. Like, for example, the hot water tap will have a red dot on it to indicate that it is hot water, and the converse will be the cold water tap will have a blue dot on it indicating that it is the cold tap. But the universe does it the opposite way. Red indicates cooler stars and blues indicate hotter stars. How cool is that? And trust me, cool in this regard isn't like maybe cold water out of the fridge or something similar. No, the coolest star that the scientists have discovered so far was 97 degrees centigrade, and that is quite hot. And remember, water boils at 100 degrees Celsius. So now, why do I assert that flat earthers are way more boring than me? Because at least I know that something amazing is happening out there in space. Like every single second, as we understand time in the scale of using time according to Earth, for every single second that goes by, something amazing is happening out there in the universe. And one of the things flat earthers don't know, or maybe they won't acknowledge it, is the invisible light spectrum. So now we are talking about radio waves, infrared, X-rays, and gamma rays. And is all around us, all the time. Flat earthers argue that we have to trust our God-given senses. That is absolutely wrong, and just wrong, because there's a whole spectrum of light which isn't detectable with the naked eye. We use all of these to our advantage also. We've even developed equipment to detect and capture these invisible colors. We are so good. Also, flat earthers, how do you explain the Hubble telescope, a marvel of our time? So the Hubble, I learned from watching Astrum recently, released a zip file of the 100 best pictures taken by Hubble, which is baffling to me. How did they decide which 100 to pick? Because from what I've seen so far, each one is more and more stunning than the last. And then I'm left wondering, actually, which one is more stunning? And I have to look all over again. Such amazing natural beauty, and we've got people denying it. That is absolutely ludicrous. So, we all basically do know that the invisible light spectrum is a thing, right? And that we see these pictures all the time. If you go to the hospital and they take an X-ray of you, that is a wavelength we cannot see with the naked eye, but we use it to see inside our bodies and through our bones. The Hubble uses these spectrums to photograph our galaxy and other galaxies out there in the universe. The Hubble has actually captured photos of the furthest distant galaxy we know of, and it's 13 billion light years away. That means we are looking very close to the time of the Big Bang, just minus about 800 million years or so, and that in itself is an amazing feat. So we've got radio waves, and that is the longest wavelength. We all know it, and we use it in our everyday lives. Radios, TVs, cell phones, walkie-talkies, and all of these uses radio waves. Next, we have microwaves, and I think that is almost self-explanatory. We have been using microwave ovens for a very, very long time. I remember my mom buying it for us in about 1984. I think I was still younger than entering my young teens. And so if that has been around in South Africa for such a long time, I can only imagine how long you Americans and the British and so on, all you guys have been using it for way longer than us. So we all understand microwaves. And then we have the infrared spectrum, and it's basically invisible heat. But as I said, human beings, we are so clever. We have also developed equipment which we can use to use this infrared to our advantage, like with cameras and telescopes and things like that. And here in South Africa, we have the Djuma Game Reserve, and they broadcast live on the internet the interactions of the animals, the cheetah, the lions, and so on. And they use a lot of infrared to showcase the animals at night. So have a look at that one if you have some time. And then we have the visible spectrum, and we are basically in the visible spectrum. It's just everything we can see with our own two naked eyes. And that would include why the sky is blue during the day and reds and oranges and yellows in the evenings and mornings. It explains how the sun's light cuts through the atmosphere, which acts like a lens, and then we see the scattered light. So the visible spectrum, just look all around you and you'll be able to see it. Then we have UV, the ultraviolet. Our sun is an active producer of this ultraviolet light, and it's produced in the entire universe by plasma, right? It is shorter than visible light, but longer than gamma rays. So what we use it for is neon signs and things like that to make things pretty and colorful. And just for you guys who may not know, it's the thing that causes sunburn. And then we get X-rays. So I've explained a little bit earlier about X-rays. Just the common use of it is to check inside our bodies. But actually, we use X-rays which show us the more violent side of what's happening in our universe, even right here in our own galaxy. It's the wavelength we use to see black holes sucking up entire galaxies and neutron stars crashing into other neutron stars and the pulsating effect of stars. We get to witness all of this via the X-rays. So the X-rays are longer than UV but shorter than gamma rays. Another point I want to mention is that the smaller the wavelength, the higher the energy. And virtually no X-rays make it through our atmosphere to the surface of our Earth. And then we come to gamma rays. Gamma rays do not penetrate our Earth's atmosphere at all. Nothing. What we do know about gamma rays is that it is some sort of decay of the particles. I'm not sure the whole entire technical details, but it is the wavelength that is given off when this decay is happening. So, what can we gather from the invisible light spectrum? Well, I've gathered that there is no way that I can trust my God-given senses in this regard, because the invisible light spectrum reveals that there is more than what the eye can see. And mostly the Hubble has shown this. But we've also got stereo satellites watching the sun. And that's how we know that the sun is a massive ball of nuclear fusion. We have been studying it actually for quite a number of years now. There is no denying that this visible spectrum is not the only thing we see. The invisible spectrum shows us umpteen more than what is actually observable with the eye. We can see the so-called invisibility of our universe, and that is awesome. So what we can do now is trust the equipment that we've developed and invented because of the previous information gathered, which is the composition of particles and atoms and nuclei and protoplasma and whatever all technical terms, the way light behaves. We've developed the equipment to witness it. So flat earthers are definitely more boring than me because they don't even acknowledge that the invisible light spectrum is a thing.